Hello, students. We're going to start talking about functions. The main focus of an Algebra 1 class is actually the study of functions. There's many ways to talk about and represent functions. And for the next couple weeks, we're going to go through a bunch of real-life examples as a whole class in breakout rooms. And then at the end, you're going to have a project where you need to come up with your own function. So here's the first type of example. There's going to be a whole bunch. They'll get more complicated as we go. This is one of the most basic. So you go to a grocery store and you buy something. And for it to be a function, you want to have something to buy that you might buy more of or less of depending on the situation, or something you're going to buy over and over and over again. So for me, I like Cool Ranch Doritos. I buy the small bags so I don't eat too much, little portion control. So what are some numbers involved in buying a bag of chips at the grocery store? Well, how much it costs. So for all of these basic examples, we're going to be talking about money. So one of the variables in our math problem is what's our total cost. We're going to use total cost a lot for the next few days. What's the other thing that depends? Like, it depends on how hungry I am. It depends on how many weeks I want to shop for. It depends if there's a pandemic and I want to stock up. It depends if I'm having some friends over and we're all going to eat Cool Ranch Doritos. So the other variable in this situation is the number of bags of chips that I buy. And if I buy more chips, it's going to cost more. And if I buy less bags of chips, it's going to cost less. In math, we call this a direct variation. You don't really need to know that right now, but that's what we're talking about. So the number of bags of chips, if I buy more, it's going to directly affect how much it costs. Let's break this down. Does anyone know what other information do I need to start this problem? Good. I need to know the cost of a bag of chips. So I looked it up online and I found that one bag of chips, it's kind of like the ones you get at 7-Eleven, was $1.98. Okay, one of those little bags of Cool Ranch. Do you think if we're doing a math model that $1.98 is better, or should we round that? I think rounding it just to play with the numbers and think of this is gonna make this easier for us. So I'm gonna say it's about $2 per bag of chips. That'll make the numbers easier to play with in our minds. Okay, so let's create a model for this. So the first model we're gonna do is we're gonna say N is the number of bags of chips. And we've already started looking at tables a little bit. F of N is the total cost. So the function, the total cost is a function of how many chips I buy. So if I buy one bag of chips, how much does it cost? Remember, we're going to round it. It is $1.98, but let's say we round it a little bit. It's going to be $2. Let's say I know I'm not going to get to the store for a few days and I like to eat a bag of chips every day. So let's say I shop for the week. How many bags of chips do I need to buy? Maybe I'm going to buy 7 bags of chips. How much is that going to cost me? $14. Good. Let's say there's a pandemic and I'm really worried that the stock of my Cool Ranch Doritos is going to run out. Let's say I buy how many weeks? Three, maybe a month worth, maybe 30 days. Let's say I need 30 bags. How much is that going to cost me in Doritos? Good. I'm going to spend $60 on Doritos. Okay, does this kind of make sense? So we can think of this two ways. We can think of this as the total cost. I should always define my variables when we're representing something in math. We like to know what the variables are. So this is the number of bags of Doritos I buy. And F of N is the total money or cost of those Doritos. I'm like a Dorito commercial today. Okay, how else could we represent that? We could take this table and we could turn it into a graph. For the graph, it's going to be a little bit annoying to graph 7 and 60. So what if I bought 3 bags of chips? That would cost $6. If I bought 5 bags of chips, that would cost $10. So one thing we do in math a lot is we represent things different ways. So this makes a lot of sense for a lot of people. They can kind of see, oh, this is the number of bags of chips and this is how much it costs. Some people like to see it visually. Graphs are really useful if you want to convince people of your arguments. Okay. So along the bottom, we're going to have N, which is the number of bags of chips. And your science teachers and your math teachers, if you're doing something real life, we want you to label your axis. That doesn't mean put X and Y. That means, what does this thing even represent? When we're doing pure math, X and Y is fine. But when we're doing a real life situation, this has a meaning. This line is telling you something. And in real life, it's telling you the number of bags of chips. So when we ask you to label your graph, that's what we mean. Number of bags of chips. And this axis, this is going to represent the F of N, or we could call it T, or we could just write the total cost. Okay. With graphs are kind of fun. You can manipulate them to make people think something different. If you're really good at creating graphs, you can kind of mess with them and try to convince people that something else is true, like strengthen your argument. So when you look at graphs and when you create graphs, and when you analyze graphs, you really want to pay attention to what these things are, what the scale is, et cetera, et cetera. So I'm just going to do 1, 2, 3, 4, 5. And we're going to show you how to create graphs using technology as well. Because it's kind of a pain to create these by hand. So we're going to show you some ways to create these using technology. And to keep it simple, I'm just going to go up by ones here. So each line on the graph is $1. 1, 2, 3, 4, 5, 6, 7. Maybe I'll make it up to 8. All right, it's a little messy. I didn't plan out my graph extremely well. But we're going to take the information here and we're going to put it into the graph. So every bag of chips, I can show you the number that represents how much it would cost. So 1 bag of chips would cost $2. If I buy 1 bag of chips, it's about $2. Our units is money and our units is number of bags of chips. 2 bags of chips, we didn't do that one. Let's take this one. 3 bags of chips, costs $1, 2, 3, 4, 5, $6. I'm going to have a point over here at 3, 6. Okay, 5 bags of chips cost $10. Ah, I don't have room. How about 2 bags of chips? $1, 2, 3, $4. This type of function is called a linear function. One other thing we like to talk about in functions, we kind of like to know where the zeros are, and that's something we care about all the way through calculus. So what happens if we don't buy any bags of chips? We buy 0 bags of chips. How much is that going to cost us? Good, $0. Okay. So this is what it would look like. This is a really discrete function. We're not going to connect the dots. It doesn't make sense to buy half a bag of chips. No one is going to sell you half a bag of chips. That doesn't really make sense. We also don't have any negatives here because you're not going to buy negative bags of chips, and you're not going to go to the store and they're not going to give you money. They're not going to say, "Oh, thanks for coming in. We're going to give you $10." And that just doesn't make any sense. So we have the number of bags of chips is just going to be whole numbers. It's called our domain. Like, you think about what's allowed to go into this function. And our range is going to be also whole numbers. Okay. In this case, they're always going to be even numbers because they're always going to be multiples of 2. Okay. So we have a table that can represent this function. We have a graph that can represent this function. Do you guys know any other ways to represent functions? There's a few more. We're going to do 2 more. Okay, one is just the verbal description. So I could write this situation out in words. We kind of had it already, but I'm going to use function vocabulary. So the total cost is a function of how many bags of chips I buy. Is a function of how many bags of chips I buy. Okay. That is another way to write this description. The total cost is a function of how many bags of chips I buy. That also represents the situation. All right, I think you are thinking about this. The last way is an equation, or it's not the last way. Another way is an equation. And these are the ways that we're going to want you to do on the project. So to write an equation for this, I'm going to write f of n, the total cost, that is equal to, now what is the rate of change here? How much is each bag of chips? $2. So 2 times the number of chips I write. So this is an equation. This is how you could represent this function in pure math. Really simple, really concise. Some of you are saying, Miss Bliss, can you say y equals 2n? Sure. But the function notation is better. And in an Algebra 1 class, we really want you to be able to use function notation. The nice thing about this is if I know I'm going to buy 360 bags of chips, I don't have to keep counting on 2 every time. I can just take 360 days, maybe 365, and then I can multiply it by 2. I want a bag of chips for every day of the year. So if I was going to evaluate that, I would just put a 365 right in here, multiply by 2. That would tell me how much money I'm going to spend on Doritos if I eat a bag of Doritos every single day of the year. So equations are really helpful if you want to do like a problem using this situation, using this function. Okay, so where's the algebra? A lot of kids can figure out how much it would cost to buy 3 bags of chips if they're $2 each. They would just say 3 bags of chips at $2 each is $6 total. Okay, that's basic math. An algebra student would see this as a function relationship, and you could represent it for an infinite number of bags of chips. So your brain expands, and you can represent it different ways. So you could find the cost of any number of bags of chips, not just 3 bags of chips. You could do 20 bags of chips. You could do 407 bags of chips, okay? Because you have a mathematical model that you can use to plug stuff in. So an algebra student would know that you would take, you want to find 3 bags of chips, you would do 2 times 3, and that would tell you the answer is 6. So this would be your mathematical model. Buying 3 bags of chips has a total cost of $6. 3 goes into the function, 6 comes out. Okay, or on a table, that would look like 3, and the total cost would be 6. Or on a graph, that would be the point 1, 2, 3, 1, 2, 3, 4, 5, 6. Have a lovely point right there. 3, 6. Okay, kind of interesting. All right, you're gonna start wrapping your brain around what kind of math problem you want to do, something that's interesting to you. I like eating Doritos, so that's interesting to me. And we're gonna get more complicated as we move forward. So the biggest takeaway is in math, we can take a real life situation and create mathematical models to represent it. And the higher you go in math, the more interesting and more complicated the mathematical models become. You can just think of COVID. Think of some of those graphs that we've seen to model the spread, etc. All right, have a good day, guys. Bye.